Hi, everyone. I'm Rico. I'm part of the City Science Group. I'm a PhD student there. And today I'm going to talk about communities without infrastructure. So as we are fixed on reaching this goal of 2.5 tons per person per year that the IPCC is setting, it's important to note that not everyone is producing the same amount of CO2. So when we compare different populations to our goal, we can see that the 50% poorest people in the planet are already well below the 2.5. If we look at the middle 40%, we have 4.8 tons. If we look at the richest 10%, we have 21 tons, which is around what we have in Kendall Square. And if we average the consumption for the richest 1%, it's at 70 tons. So in fact, the richest 10% is accountable for 50% of the global CO2 emissions. And sadly, on top of this, the impacts of climate change are not equal either. So typically, the regions that tend to be the most vulnerable are not the ones that are producing the most CO2. And this is because they don't have as many resources, of course, but this should be solved. So as we're addressing climate mitigation with some of the technologies that we've seen throughout the conference, this means reducing CO2 tons through better energy systems, etc. We must also be thinking of using that CO2 gap to create better technologies for climate adaptation. And specifically talking about how do we manage to secure energy resources for these communities, our food resources for the communities, and our water resources for the communities. So typically, solutions tend to look like this. This is a desalination plant. And this is really good, but the problem with them is that they're very costly. They rely on high technology development, and we're running out of time. So at City Science, we're thinking of different systems that could help us to better address these problems. And we believe that systems that are community scale, low cost, lightweight, and distributed can help us to better address these problems. So to better develop the ideas that we have around the systems, we're working in Mexico with an informal community in the northern part of Guadalajara. And this is a community that has been suffering with water scarcity problems for decades. And neither political agendas nor technological agendas have been able to solve them. So when we went into the community, we decided to, first of all, try to understand the water cycle that they have. So all the way from getting the water, storing, using it, and disposing of it. And we quickly realized that there are a ton of social, political, and environmental issues within the community that don't allow us to just implement one technology, so we just want to take all of them into account when we're designing the solutions. So for example, when they get the water, they tend to do it from illegal takes. Sometimes they capture it from the rain, and sometimes it arrives in these water trucks, which are in many ways controlled by organized crime or organized criminal organizations. So it's really hard to get a steady stream into their households. Once they get water into the households, they store it in these buckets or underground. And to store it underground, they need to dig quite a big hole. So it's very hard to do so due to the geography of the place. And then when they use it, they have no way of knowing the quality of water that they're using. So sometimes they use bad quality water for drinking or for cooking. And furthermore, they don't have a way of knowing how much they're using. So they tend to make it to the end of the month without water. Finally, when they dispose, they do so in the streets because they don't have formal sanitation infrastructure. And this leads to clear health and health risks to the community and environmental risks to the water that is around. So we decided to focus on use. And to do so, we developed a set of distributed sensors that help us to measure the reserves that the household has. They also measure the quality of water that is within those reserves, and the usage patterns that the household or community has. So we prototype downstairs some low-cost, low-power sensor systems, and we hope that when we deploy them, these sensors will allow the communities or households to better manage the usage of the water, understand the quality of the water that they have, so that they can use the highest quality for drinking and cooking, and the lowest quality maybe for watering the plants or for the restroom. So this is an example of the prototype that we have downstairs. It's a bucket, wirelessly connects to a sensor relay. And you can imagine that these buckets will be placed around the household so that you can map out the amount of water that is being used in the restroom, in watering the plants, in cooking, in showering, etc. And we do acknowledge that this is only one part of the solution. So we see these technologies more of like a constellation of solutions that will help us tackle every detail of this cycle. And also not just the cycle in Lomas, because as we know, maybe the context of Lomas is very different than other communities around the world. So that's why these technologies need to be lightweight, low cost, and distributed so that they can fit better with the context of the community where they're being deployed. And so as we look into a changing climate, I believe that the technologies that we design need to be as dynamic as the challenges that we will be facing. And I think that this set of characteristics will help us to better develop these technologies, and furthermore allow us to understand and have a better relationship with the resource and the consumption behavior that we have, leading us to a more sustainable planet. Thanks so much. With that, I give the word to Jacopo Bongiorno to talk about high-density power.